Hi Chris, thanks for your question. Today we're going to be solving for the angle theta between two vectors u and v. The first thing I'm going to do is rewrite this using traditional vector notation so I can identify the components a little easier. First component of v is just 1. Now to solve for theta, we're going to be using the dot product. And the dot product tells us that u dot v will be equal to the magnitude of u times the magnitude of v times cosine theta. Something that's very important to note when you're using the dot product to solve for theta is that theta will now be between 0 and 180 degrees. So when we find out what theta is, it will either be in the first quadrant or the second quadrant. The third and fourth quadrant are now completely off limits. So let's go ahead and fill this equation in as much as we can, and then we're going to solve for cosine theta. U dot v is just calculated component-wise, so it will be the first component of u times the first component of v, and we'll be adding that to the second component of u times the second component of v. On the right side of this equation, the magnitude of u is equal to the square root of the first component of u squared plus the second component of u squared. Since we're squaring it, I'm not going to put the negative in there. I'm just going to write 3 squared since it will be positive anyway. We multiply that by the first component, the square root of the first component of v squared, plus the second component of v squared. Again, I'm leaving out that negative because my final answer will be positive in that case since I'm squaring it. And then that gets multiplied by cosine theta. Simplifying this all down, I have 2 plus 6, so 8, is equal to the square root of 4 plus 3, so the square root of 13, times the square root of 5, times cosine theta. Simplifying again, it looks like I get 8 is equal to the square root of 65 times cosine theta. So I have nothing else to solve for in this equation except for cosine theta now, which is exactly where I want to be. I am now going to solve for cosine theta, and I find that cosine theta is equal to 8 over the square root of 65. Once I've solved for cosine theta, I have 2 directions I can go. To find theta, if I recognize the cosine of theta as the cosine of one of the 3 basic angles I learned in trig class, pi over 6, pi over 4, or pi over 3, then I can solve for theta that way. If I don't recognize it as the cosine of one of those 3 basic angles, then I'm going to have to use an inverse trig function. In this case, I'm stuck with the inverse trig function. So here I say theta is equal to the cosine inverse of 8 over the square root of 65. So if I want an approximation, I can say that theta approximates 7.13 degrees. So when I solve for theta, I see that I'm up here. It's a tiny little angle. It's somewhere down here somewhere. So that will be your final answer. 7 approximates 7.13 degrees, or if your teacher desires an exact answer, this would be your answer. Thank you for your question. I hope this has been helpful, and I look forward to answering more of your questions using Snap Math in the future.